what are the oxidation numbers of sulfur in each? So now this one is asking for the oxidation number, not the formal charge, okay? And to way we find oxidation number, there's actually a different set of guidelines and rules that we need to follow. Okay, so B is SO3, C is H2S, and D is CaSO3. Okay, so now for this, the way we find the oxidation numbers, okay, is that when we're working with each one, I'm actually going to give myself more, actually I'm going to write it here on the side, SF6, alright? So, halogens typically, and there are maybe a few exceptions here and there, but halogens typically have an oxidation number of -1, okay? Because it has an oxidation number of -1 and there's 6 of them, the total this has to account for is -6. So for this to have a total neutral charge, it is being shown, sulfur needs to be +6. And because there's only one of them, this oxidation number of sulfur here is +6. Okay? So that is a trick here, is that the goal for each of these questions that you want to use the given to give you the unknown. Okay? So SO3, right? Oxygen specifically, and this is specific to oxygen, likes to have an oxidation number of -2, except for like situations where it's like hydrogen peroxide, for example, to where in H2O2, where oxygen there is -1, but in most other cases it's -2, and there's 3 of them, so there's still going to be -6. So coincidentally, this sulfur here actually has the same oxidation charge of +6. Now, H2S. Alright, so with this being said, alright, okay, good. H2S, hydrogens, except for like in situations where hydrogen is like bonded with like another metal, for example, like LiH, lithium hydroxide. No, that's not it. Lithium hydride will be what it's called. Hydrogen typically just likes to function as +1, except for those conditions when it's bonded with metals. And here it's bonded with another non-metal, which is sulfur. And because there's 2 of them, that's +2. So in this case, sulfur has an oxidation number of -2. And now for the last one, this is kind of a little bit of a behemoth here, CaSO3. There are 2 ways to solve it, but the second way kind of needs you to know the your sulfates, sulfides, phosphates, and stuff, which is not really how you want to approach this, because sometimes if you don't know, you kind of get yourself lost. We'll approach it the same way with the givens, okay? Oxygen still likes the -2, and you know, that means it's going to be -6 in total over it. Calcium, because it's a metal, like specifically the alkali and alkaline earth metals, they usually just follow the periodic table in regards to what they like to do, which is give away 2 electrons. So that is what that means there. In fact, all these numbers you're seeing there, I realized I wasn't really explaining where I got them. Fluorine is -1 because it likes to just accept 1 electron. Oxygen really just likes to always accept 2 electrons. Hydrogen always likes to donate 1 electron, except for the situations, as I mentioned, where it's bonded with another metal. And calcium, in this case, always likes to donate 2 electrons. So for this whole thing to be a positive, a neutral charge, the sulfur here has to be +4. So that is what we have here for the oxidation number of the sulfur in each. And you're probably wondering, but wait, sulfur is like right under oxygen. How come it doesn't just go with the -2? That's why it's always good to just go with your givens, because those givens are written as givens because those are the ones that take priority in a sense. As you can see, sulfur kind of switched because based on what it was bonded with, it would take the lesser priority than whatever it was bonded with, and they would do their thing first, and sulfur would accommodate. Okay, so exactly as you see here, oxidation is +6 for sulfur in the first one. Second one is also +6. Third one, as you see here, is -2, and the fourth one, the oxidation is +4. So this is correct. And now is one of the questions 16.